These absolute value inequalities require you to think deeper. You need to do more exploration. So the first one, pretty basic. Absolute value of x is in between 1 and 10. So how do we solve for x? So first of all, 1 is positive, 10 is positive. I can see that x cannot be equal to 0, right? So x cannot be 0. So there are two cases. So the first case is when x is negative. So when x is negative, can x be negative? Absolutely, right? So x can be negative 5, right? Negative 5, once you take the absolute value, you have 5. 5 is between 1 and 10. So you have 1 less than or equal to negative x less than or equal to 10. And then you divide each side or multiply each side by negative 1. You have negative 1 greater than or equal to x greater than or equal to negative 10. Let's double check this. Negative 1 is greater than negative 10, right? And then I said this many times. I would like to put the smaller number on the left, the bigger number on the right. So you have to reverse the order of this. You have negative 10 less than or equal to x less than or equal to negative 1. So this is the first solution set. And then the other solution set is, what about x is positive? So when x is positive, what do you have? You have 1 less than or equal to x less than or equal to 10. That's it. So you have two solution set. Okay, can you graph them on a number line? Absolutely. So we draw a number line, and then we have negative 10 to negative 1, and then we have 0 in the middle, and then you have 1 to 10. 1 to 10. They all have an equal, right? So this is the solution set, and then the other solution set is right over here. So when you pick a number that satisfies this inequality, this compound inequality, the number must be between negative 1 and negative 10, including the upper limit and lower limits, or 1 to 10, including 1, including 10. So you can check my work. Let's say x equals to 3.6. So 3.6 is right over here. That satisfies the inequality. How about x equals to negative 9.1? Negative 9.1 is right over here. That satisfies the inequality. Negative 9.1. Once you take the absolute value, you get a positive 9.1. Positive 9.1 is between 1 and 10. All right. Okay, how about a fraction like this? How about a fraction like this? This time you have an x in the denominator. So whenever you see this, I need to point out something extremely important. Whenever I see a fraction, especially when there is an x in the denominator, I have to quickly point out that for x plus 3, this cannot be equal to 0. No, x plus 3 cannot be equal to 0. So x cannot be equal to negative 3. So tell me what happened when x is equals to negative 3. You have a 0 in the denominator. How about 1 divided by 0? Is that defined? No, right? So whenever you see a fraction, no 0 in the denominator. So x cannot be equal to negative 3. Okay, and then the next step is I will get rid of the fraction, I should say get rid of the denominator by multiplying x plus 3 on both sides. So let me match the color code. So you have 1 greater than 2 times absolute value of x plus 3. You have this. Okay, so in case you don't know why we do that, we can make a side note. So let's just choose a different color. Let's say you have 10 divided by 2 greater than 1. So that is true, right? 10 over 2 is greater than 1. You can get rid of the fraction by multiplying 2 on both sides. And 10 is greater than 1 times 2. That is still true, right? Which is exactly what I just did. And then I need to have the absolute value stands on one side. And then I will just divide both sides by 2. So I have, I think I should pick the other purple, right? So 1 over 2. Okay, I will just stick with this. X plus 3. And whenever I solve an inequality, especially when there is an x value, I would like to have the x on the left hand side. So that means I have x plus 3 in absolute value. You see that this, the less than, is pointing at the absolute value. So this will be the less than 1/2. The less than, the sharper end, is pointing at the x value. So when you reverse the left and right, be careful. Okay, is this in between or the opposite? So this one is in between because the less than is pointing at the absolute value. So that becomes x plus 3 between negative 1/2 and past the 1/2. No equal. Negative 1/2 and past the 1/2. And then you go ahead and add 3 on each side, minus 3, and then minus 3. And then you have negative 1/2 minus 3. 3 is the same thing as 6 over 2, right? Less than x, and then less than 1/2 minus 6 over 2. 6 over 2. Not 3, 6 over 2. Okay, so this will be a negative 7 over 2 less than x, and then this is a less than negative 1/5 or 1 negative 5 over 2. Okay, so I am going to box this. Should I approximate the fraction? The answer is no. You should not approximate the fraction, especially when you are doing this, when you are doing online homework. Do not approximate the fraction unless they tell you to do so. But in the next step, it is more convenient to approximate them to fractions. So negative 7 over 2, that is negative 3.5. This helps you to understand the next step better. Less than x. Oh, you know what? Here, I should not box this. I just make a mistake. If you make such follows the mistake, is like just erase the box because we are not done yet. That is, boxing this is not right, because once I box this, I call that my final answer, right? Which is incomplete. Why is that incomplete? Because I have to put a comma and then emphasize that x cannot be equal to negative 3. Do you see this? Negative 3 is actually between these two numbers. It's pretty hard to see, right? Because they are in fraction. So that's why I said for reporting answers online, that's it. But to understand this better, it is better to approximate them to the fraction to that decimals. So this is a negative 3.5 less than x less than negative 2.5, and x cannot be equal to negative 3. So let's put this on a number line. I think it is even better to put this restriction in red. So x cannot be equal to negative 3. And then I have a negative 3 right over here. And then this is a 3.5 in negative, of course, negative 2.5. So negative 3 is between negative 3.5 and negative 2.5, right? You want to between them. So that's why I put this problem for an example. You don't want x equals to negative 3, right? So this should be a not equal. Then you have to punch a hole right here as well. You have to mention this restriction, because when you draw your solution set, you have to skip 3. So you have to jump over at x equals to negative 3. So the solution set is from negative 3.5, we take a stop at negative 3, and then from negative 3 to negative 2.5. We have to make a jump. So for the negative 3.5, you should put a negative 7 over 2 instead, because for sometimes when you get a fraction, most likely there is an approximation. So that's why when you do homework online, they don't want you to use approximation. Okay, so that is the solution. So this is the interval, the interval of the given inequality, and that is also that's the number line. Okay, I have one more problem for you to solve. So let me go to that problem. So that problem is, so this one is an in between, right? Let's make an opposite. How about we switch to this color? So this time we have 1 over absolute value 2x minus 3, let's do a less than or equal to negative 4. So first of all, like the previous problem, multiply the absolute value on both sides, 1 less than or equal to 4 times the absolute value, because I want to let the absolute value stands on one side alone. Divide 4 on both sides, you have this 2x minus 3. Remember, the greater than is facing the absolute value, so you have an absolute value 2x minus 3. Let me just move up. Greater than or equal to 1 over 4. Okay, make sure you copy this correctly. The greater than is facing the absolute value. So since it is facing the absolute value, we have to break this down into two inequalities. The first one, just remove the absolute value. Let's solve that. You add 3 on both sides. So 3 will be a 12 over 4. So you have a 2x greater than or equal to 13 over 4. And then once you divide 2 on both sides, so you have to divide 2 or multiply both sides by 1/2. So the bottom becomes an 8. So x greater than or equal to 13 over 8. 13 over 8. Okay, so before we move on to the second part, do you see that I missed something extremely important? Yeah, right, the red. Do you see the denominator here? This, the 2x minus 3 cannot equal to 0. And then the 2x cannot equal to 3. And then you have x cannot equal to 3 over 2. So 3 over 2 is approximately 1/2. And then the 13 over 8, this one you don't need to approximate. The 13 over 8 is 3.25. And then how about the second inequality? The second inequality is, so the first one you have that. And then the second one will be 2x minus 3. Watch, reverse, and negative the other side. Got that? So 2x less than or equal to negative 1 over 4, you plus 3. So that will be a 12 over 4. So this is a 2x less than or equal to negative, oh, it's actually a 11 over 4. 12 minus 1, which is a 11. 11 over 4, so we have a 11 over 4. And then we multiply 2 on both sides. No, not multiply 2. Multiply 1/2. Okay, 13, 12 minus 1, 11, and then times that. You have x less than or equal to. So that will be a 11 over 8, and then you box that, and then don't forget that you have to mention the restriction as well. And then 11 over 8, that is approximately, it's not approximately, exactly 1.375. Okay, let's draw a number line. So number line, we have that. And then we have 1.3 and then 3.25. So we have 1.375 and then a 3.25. So this is a 13 over 8. This is 11 over 8. And then where is my 1.5? My 1.5 is like right over here, right? So 1.5, which is 3/2. So x cannot be equal to this. You know what? I should put that in red. So this is 1.5 equals to 3 over 2. Equals to 3 over 2. And put this mark in red. No this. Okay, so x must be less than or equal to 1.375. So must be less than or equal to 1.375. So less than or equal to is, you go to this side, and then greater than 3.25, which is right over here. And then as you can see, in this solution set, the restriction doesn't affect anything. So compared to the previous problem, so in the previous problem, the restriction affects the intervals, right? So because if you don't mention this, you will just include the negative 3. once people say, okay, what about x equals to -3, and then you will screw up the entire problem. So this one, it doesn't the restriction 1.5 doesn't affect anything. So you have 3.25 to positive infinity, and then from negative infinity to 1.375. I believe that when you do homework online, they would like you to use the fraction instead. Okay, so just read the problem carefully, see what they want. Because if they don't want you to approximate, but you approximate, they will mark that as incorrect. So you did all the work to reach to an incorrect solution. That is not worth it because you did a lot of work, right? If they want a fraction exact value, then just give them the exact value. If they say approximation is okay, then approximate. All right, read the problem very carefully. All right, so that is the end of this video. If this is something that you would like to see, you think this is helpful, give the video a thumbs up, subscribe, stay tuned for more video in the future. As always, I will meet you all in the next lesson. Signing out.